So in this video, I want to walk through with you on simplifying expressions without leaving negative exponents. This particular one says simplify each expression below leaving no negative exponents, and I want us to walk through it. So our first problem really is square root of 200 minus square root of 32. So what they want us to do is to really simplify this expression without leaving exponents. How do we simplify this expression? We simplify this expression by looking for numbers in both of these square roots that have a perfect square. A perfect square could be something like, oh, if I do 10 by 10, I get 100. If I do 2 by 2, I get 4. If I do 4 by 4, I get 16. If I do 5 by 5, I get 25. Those are perfect squares. So in this particular case, what we're doing really, we will take a look at the first expression, which is the square root of 200, and say, which numbers can I multiply in there to get 200, but can have perfect squares? In this particular case, I would go and say, if I say 2 times 100, for instance, I know that 100 has a perfect square. If I go to 32, for instance, if I go to 32, in this particular case, square root of 32 is the same thing as which numbers? 8 times 4, right? You would get 32. So in this particular case, you could even simplify and go further and say, which numbers in 8 can I multiply that do have a perfect square? I mean, you can see something in there. You could say 2 times 4. So you could simplify 8 and use 4. You could also use my first statement that I said earlier, and I gave an example of 16. So in this case, instead of saying 8 times 4, you just go ahead and say 16 times 2, because then 16, you know, if you have 4 by 4, you're going to get 16. So that could work. So these things can work in different ways. You can find whichever number works for you. Either way, you're going to end up with the same result. So in here, if I use 2 times 100, remember, if you have a square root of m times n, is the same thing as the square root of m times the square root of n. So in this particular case, if it's a square root of 2 times 100, it's the same thing as square root of 2 times the square root of 100. And remember, we just talked about this. So what is the square root of 100? That's 10. So you would have 10 square root of 2 minus, now let's look at this other side, the remaining side, which is, we said earlier, so this is going to be square root of, you could have used the 16, I used the 8, so you could say square root of 4 times square root of 2, that's the 8 times, which is 4 times 2, then times the square root of 4, which would give you 10. I went the longer way, minus, what's the square root of 4 is 2. What's the square root of 4 is 2. Square root of 4 is 2. So you would have 4 times the square root of 2, the one in the middle. Because this one gives you 2, that one gives you 2. So 2 times 2, you get 4. Now you have the square root of 2. So this one ends up giving you 6 square root of 2 as your final answer. Now, I want us to try out a different problem here. And that problem is, we will be simplifying 3x to the power of 3 over 2 times y cubed over x squared times y to the minus a half. Everything to the power of minus 2. So the way I want us to go about this one, let me get us some space here so we can proceed. So the way we are going to work through this one is essentially the same way that we just worked through the previous problem. So simplify this expression without leaving a negative exponent. What we will do here is that we will start off by saying, okay, so if I have, remember what we said earlier, that if you had, say, anything in here, nm for instance, to the power of x, right, is the same thing as n to the power of x times m to the power of x. So that is what that means. So everything in the parentheses here is covered by the same power. So what I would do is that I will pull out my whole number, which is 3, and once I pull it out, it will be 3 to the minus 2 times everything else, right? Which is x 3 over 2 y cubed over x squared y minus a half. And the reason I chose this number is because, this problem is because it combines some of the things that we just talked about. Remember how we had the multiplication, and then we also had the division. So this kind of combines all of those concepts we just did. And I'll move this one over here. So what does this one leave me up to? So 3 to the minus 2 is essentially the same thing as saying anything negative, anything to the power of a negative number is essentially a fraction. So if, say, I had, I will use m. If I say I had m to the power of minus n, this is the same thing as saying 1 over m to the power of n. So now n becomes positive. The power becomes positive. So if I have 3 to the minus 2, is something as saying this is equal to 1 over 3 squared, which is 1 over 9. So we know at least part of this expression that we're going to have a 1 over 9. Now let's continue with the other expression. So remember how we said that if you divide something, say m over m, right? Remember that? And then this is k to the power of k, and that's the power of n. And this is the same thing as saying m to the power of n minus k. So that's what we see right here, right? When we look at x cubed, x to the 3 over 2, not x cubed, sorry. So x to the 3 over 2 over x squared down here is the same thing. Now you can bring it up here and say, well, 3 over 2 is smaller than x squared. So instead of me taking x squared up, I will instead take the x to the 3 over 2 down, because it makes my life easier in doing the subtraction. So what I would say is, so this is the same thing as I take the y up, so I say y to the 3. Now remember, every time a number goes up on top of a fraction or goes down, the power of that number changes. Like what we saw here, that it became positive, right? 2 became positive. Here it was over 1, so 3 to the minus 2, this is whole thing over 1, and now once the 3 crosses to below to become a denominator, that power becomes positive. It's the same thing if this 3 goes up, that power becomes, if that 3 goes up, that power becomes negative. So here in this particular case for y, you are taking this number right here up. So what's going to happen to this negative? It's going to go away, right? Why is it going to go away? Remember what we said here. If you have m to the power n over m to the power k is equal to m to n minus k. Now, if you put here your n, in this particular case, would be 3, and your k here would be 1 over 2 minus 1 over 2. What happens? You have two negatives. You have this minus, and you have the minus there. They add up, they become a positive. So it would be 3 plus 1/2 over x squared minus 3 over 2. Do not forget the 1 over 9 here, which came from the 3. So I would put 1 over 9 there. It has already seen its to power negative 2. So now this has power negative 2. And what this one will give me is, what is 3 plus a half? Is essentially saying 3.5, which gives you y to the 7 over 2 divided by x squared minus 3 over 2 is the same thing as saying 2 minus 1.5, which is going to give you x to the power of 1/2. Again, to the minus 2, and this is going to be 1 over 9. Now, when you move this, if you want to make this positive again, the rule is the same. So if I'm going to make this positive, I will have to switch between these two. So x will go on top, y will go down, so such that now I have my final expression as 1 over 9 times x to the power half times 2. Now that 2 is going inside, over y to the 7 over 2 times 2, and that cancels out, the 2 cancels out, and your final expression will be x over 9y to the 7 as your final answer. I hope that helps you out. If it became confusing, please do a little bit more practice with it, following through everything that I'm saying and doing, and I hope that helps you out.